Explains why the corn is ready to be harvested. Bo.
High in the Andes of southern Peru, where steep mountains carve narrow valleys and ancient irrigation channels still trace the contours of the land, a crop grows that most of the world has never truly seen. It is corn, not the uniform yellow kernels stacked in supermarkets, but corn in colors, shapes, sizes, and textures so diverse that it looks almost unreal. Some ears are deep crimson or violet, others are pearl white and as large as a human hand. Some varieties are tiny, delicate, and ancient, cultivated continuously for nearly 2,000 years. This region is known as the Sacred Valley of the Incas, one of the original centers where corn was domesticated and refined into hundreds of unique strains. For thousands of years, Andean farmers selectively bred maize not only for food, but for resilience, ceremonial use, medicine, trade, and survival in extreme microclimates. Long before modern genetics existed, this valley became a living laboratory of agricultural innovation. Today, that genetic legacy is quietly disappearing. Modern commercial farming favors a single giant variety of corn that grows exceptionally large, but only in this narrow band of altitude and climate. Its success has pushed many ancestral strains toward extinction. What once existed as a balanced ecosystem of diversity has begun collapsing into monoculture. Yet one man has spent more than 15 years trying to stop that loss. His name is Amado Lopez Moravilaca, and his personal mission is to recover, preserve, and protect Peru's ancestral corn before it vanishes forever. The Sacred Valley stretches along the Urubamba River between 2,700 and 3,000 meters above sea level. Its geography creates dozens of microclimates, slopes with different sun exposure, valleys that trap moisture, ridges that remain dry, and elevations that vary dramatically within short distances. Each microclimate shaped the evolution of a specific corn strain adapted to that precise environment. Some tolerate frost, others thrive in intense sun. Some mature quickly, others develop slowly with denser kernels. This diversity is not accidental, it is the result of centuries of careful selection by indigenous farmers who understood their land with extraordinary precision. Corn is more than a crop here. It is embedded in daily life, cuisine, trade systems, spiritual rituals, and cultural identity. It appears in breads, stews, fermented drinks, ceremonial offerings, and barter networks that once stretched across the Andes from Colombia to Chile. Even today, small farmers remain largely self-sufficient. Families often cultivate multiple plots scattered across different elevations, growing not only corn, but quinoa, beans, squash, herbs, fruit trees, and medicinal plants. Seeds are saved year after year, preserving genetic continuity that extends back through countless generations. In one village of the Sacred Valley, a local woman casually offered visitors a small bundle of seeds, 16 different corn varieties grown on her family's land, passed down through generations. What appeared like a simple gesture represented thousands of years of agricultural knowledge embedded inside each kernel. But this ancient system faces growing pressure. One variety of corn, locally known as giant white corn, dominates the valley's commercial production. It grows nearly 3 times larger than standard corn, producing massive kernels prized in international markets. The crop thrives only in this specific altitude range and cannot be grown elsewhere at scale. Its economic value has encouraged farmers to replace traditional varieties with this single strain for export. As more land converts to giant corn production, older varieties disappear. This is the problem that Amado recognized more than a decade ago. Living in the Sacred Valley, he watched ancestral corn strains slowly vanish as farmers prioritized export crops. Entire genetic lines that had survived for centuries were being abandoned. Seeds were lost, knowledge faded, diversity collapsed. Rather than accept that loss, Amado began collecting endangered corn from remote villages across the valley. He planted them, saved their seeds, cataloged their traits, and built a living genetic archive on his own land. Today, he maintains nearly 30 distinct varieties, each preserved through active cultivation rather than frozen storage. His home has become a small museum dedicated entirely to corn, a physical record of agricultural heritage that might otherwise disappear. Some of the varieties he preserves are among the oldest continuously cultivated crops in the Americas. One small red corn strain has been grown for approximately 2,000 years. Others display rare pigmentation, high protein content, or unique medicinal properties. The most important strain in his collection is known locally as the mother of corn. This ancestral variety contains genetic markers capable of producing many other corn types when cross-pollinated. In genetic terms, it holds exceptional diversity. Selecting this strain alone preserves the potential to regenerate multiple lost varieties in the future. Corn diversity is not only cultural, it directly affects nutrition. Darker colored corn contains higher protein and antioxidant levels than pale commercial strains. Some varieties reach protein levels approaching 17%, making them nutritionally significant for communities that rely heavily on plant-based diets. The way corn is grown here also challenges modern agricultural assumptions. Fields are not cleared of so-called weeds. Instead, diverse plants grow alongside the corn: flowers, herbs, legumes, squash, and volunteer vegetation. These plants attract pollinators, stabilize soil moisture, reduce pest outbreaks, and create a balanced micro-ecosystem. The soil remains shaded and biologically active without chemical fertilizers or pesticides.
We just have to pick a little bit of corn for the store. Generally, he starts picking.
This method mirrors ancient agricultural systems known across the Andes and Mesoamerica, where biodiversity itself functions as the primary defense against disease and crop failure. Rather than eliminating competing plants, farmers integrate them. The valley's agricultural diversity may have influenced Andean engineering as well. Some researchers propose that the irregular, non-linear stone architecture found at sites such as Sacsayhuaman and Ollantaytambo reflects natural organic patterns observed in corn and plant growth. These asymmetrical interlocking stones create earthquake-resistant structures that disperse seismic energy rather than concentrating it along rigid fault lines. The architecture behaves more like a living system than a mechanical structure. Whether intentional or coincidental, the connection illustrates how deeply agriculture shaped Andean innovation beyond food alone. Corn also powered the ancient Andean trade network. The Incas developed one of the most sophisticated road systems in the ancient world, linking high-altitude settlements with coastal and jungle regions. Corn served as a primary exchange commodity, traded for products that could not grow in the valley, including potatoes, coca leaves, tropical fruits, and medicinal plants. Fermented corn drink known as chicha played a central role in ceremonial life, diplomacy, and community gatherings. Even today, red cloth markers hang outside homes indicating fresh chicha is available that day, preserving a living tradition thousands of years old. Ironically, the same agricultural success that built ancient civilizations now threatens genetic diversity. Global demand for giant corn incentivizes monoculture. While economically beneficial in the short term, monoculture reduces resilience. It increases vulnerability to disease, climate shifts, and soil degradation. Once genetic diversity is lost, it cannot easily be recreated. Amado's work addresses this risk directly. By maintaining living seed banks rather than frozen archives, he ensures that the corn continues adapting naturally to local conditions. His fields act as evolutionary laboratories where resilience evolves in real time.
It goes into the production of other types of crops. Maybe you can tell us.
Walking through his plots feels like stepping backward through agricultural history. Ancient irrigation channels guide water across terraced slopes. Orchards blend with vegetable patches. Corn grows beside avocado trees.
Some farmers had to throw out their entire crop.
24-Hour News 8's Marvis Herring explains why.
Squash vines, herbs, and medicinal plants. Each plot reflects centuries of trial and error knowledge encoded into planting patterns. Harvesting reveals how dramatically different each variety is. Some ears are compact and jewel-toned, others are pale and massive. Kernel spacing, hardness, sweetness, and color vary widely. Each strain serves a different culinary or cultural purpose. Even flavor profiles differ significantly. Some corns ferment better for beverages, others grind into fine flour. Some resist drought better, some mature faster. Diversity is not aesthetic, it is functional survival. Despite this richness, preserving ancestral corn faces growing obstacles. Younger generations migrate toward cities. Traditional knowledge erodes. Market forces favor standardized crops. Climate variability alters rainfall patterns. Without intervention, many varieties may vanish within decades. Amado's project demonstrates that conservation does not require massive institutions.
Farmers across Green Country are preparing to harvest corn, one of the largest harvest seasons of the year.
It begins with individual stewardship, community engagement, and cultural continuity. He collects seeds directly from elders, exchanges knowledge with neighboring farmers, and teaches few consumers ever see the genetic richness that once defined it. Visitors about genetic preservation. His work has attracted attention from agricultural researchers who recognize that ancient crop diversity may hold solutions for future food security. As climate change increases droughts, pests, and soil stress worldwide, resilient genetic traits preserved in traditional crops may become invaluable. The Sacred Valley's corn is not merely a historical artifact. It is a living archive of biological intelligence accumulated over thousands of years of human observation and experimentation. Modern agriculture often measures success in yield per acre. Ancient agriculture measured success in stability across centuries. That distinction matters. As global food systems grow increasingly centralized and vulnerable, small genetic reservoirs like those protected by Amado may determine whether future generations retain the ability to adapt. Corn began its global journey in places like this valley. From these mountains, it spread across the Americas and eventually the world, becoming one of humanity's most important crops.